Good afternoon, everyone. Welcome to today's Sec 4 E-Math lesson with me, Teacher Jason, over here as usual. I hope you guys are enjoying your June holidays because I am too, even though a bit unfortunate here. But regardless, let's get to today's lesson started with our Sec 2 E-Math lesson for today. Alright, so regardless, let's get it started. Alright, moderator, I started recording already on the OBS setup. So yes, let's get started. No, there's no Sec 2. Yes, hi Isabel, there's no Sec 2. Today is Sec 4. Yes, now it's Sec 4. Alright, so let's get started. Did I say Sec 2? Sec 4. I say Sec 4. Yes, Sec 4. I might have said it wrongly, but it's Sec 4 E-Math. Yes. Okay, so general rules, just be patient, understanding, observe gracious and respectful behavior even in digital space. And lastly, ask good and relevant questions. And it might be me saying Sec 2. So never mind. Nevertheless, let's get started. And today, as usual, we are going through more revision lessons, but this revision lesson is going to be very, very interesting because what happens if you have actually seen questions at your side, it might be concepts whereby it is just segregated. Okay? Segregated by itself, so like congruent similarity by itself, and the test by itself and what's not. But you are going to see what happens when all of the concepts are combined, and it's going to be a little bit harder. But nevertheless, let's see how we can get them today. So regardless, first let's have some revision. So over here, so let's look at congruent figures. So for congruent figures, does anybody know for my corresponding angles, what do they have to be? Can anybody tell me? For congruent figures, what do my angles have to be for the corresponding ones? Okay, I'll just wait for a while. Okay, I hope you all realize already, congruent figures, okay, my angles have to be the notion of equal, and because they have to be exactly the same, my corresponding sides have to be equal as well. Now for similar figures, it has to be a bit different because though they are similar, which means their corresponding angles are equal, the corresponding sides follows the notion of proportional. That means they follow a certain ratio. Alright, so that's the notion of proportional ratio. So that's very, very important to follow over here. With congruence and similarity, we jump onto this thing called congruence test. Alright, congruent test. Alright, very, very important over here. So there are a few congruence tests over here. SSS, basically side, side, side. So just showing that 3 pairs of congruent corresponding sides are equal. And lastly, SAS, show that 2 corresponding sides are equal. And because, take note, my A is right in the middle of SAS. So it has to be a side angle followed by a side, which means my angle has to be included by the side. So SAS. Very, very important down there. SAS. Alright, very, very important. Now this is for congruence test, and next one for my more congruence test. In this case, you realize for my congruence test, for this one, AAS or ASA, it doesn't matter because whether I have the included side or the side that's not included, the congruence test will still work. So in this case, you just have to ensure that 2 pairs of angles are equal and 1 pair of corresponding sides are equal. And lastly, what happens? RHS, R represents the first thing, right angle. Okay, R represents my right angle. Next one, H represents the hypotenuse. I hope you all understand what the hypotenuse is in the triangle. It's basically the longer side in the right angle triangle. And lastly, also 1 pair of corresponding sides. So just recap over here, congruence test we have for SSS, SAS, and for this slide, AAS or ASA. Last one, we have RHS. So these 4 of them are very, very important for congruence tests. Okay, now moving up to that, we have actually one of the very interesting questions that can come up for congruence tests. So let's take a look. Oh, before that, let's move on first. For similarity test, I forgot, so sorry about that. Because for congruence, next up, we have similarity as well. So for similarity, we have AA. We just have to show 2 pairs. Now for that, I'll just stop for a while, and can anybody tell me, why don't I need to show my last angle for similarities test? for triangles. Can anybody tell me why? Very interesting thought here. Very good, Isabel. That's correct. Anybody else still wants to try? Okay. Why is it that for similarities tests for triangles, I just need AA? I don't need AAA. Sounds weird, but yes. Okay, I'll just wait for a while. Right, seeing the string of response. Okay. Alright, okay, most of you all have the same response as Isabel. Very good, because if we call the angle sum of triangles, there are only 3 angles in the angle sum of triangles, right? And the angle sum of triangles is fixed at 180. So if 2 of them are the same, the last one is definitely the same. So that's why for similarity tests, AA is enough. Next up, for my similarity test, I just have 2 more to go, which is in this case triple S, which is in this case my 3 pairs of corresponding sides. But take note, it's no longer the same now, but is proportional. The difference between the difference between, why did I say corresponding? Sorry for that. The difference between congruence and similarity is the word proportional. Similarity, we follow the word proportional. Alright, so take note over there. And lastly, SAS. Similar to the congruence one, I need to show the corresponding sides, and included angle are there, but the difference is for corresponding sides, proportional. The sides have to be proportional. Just take note that is the main difference for similarity and congruence. Okay, now with this notion, finally, we are getting to the notion of how, in particular, a type of question can come up for, say, congruence. In fact, not just by a concept by itself. So, let's get to it. So, this is a very standard kind of question whereby the angles may not be given to you, okay, and you have to decipher accordingly to how you prove congruence, okay, over here. So, let's see the information we have first, okay. So, we have, okay, they didn't draw for you, but since they tell you so, you can assume that. So, AB is parallel to CD and AB equals to CD. Okay, each of them is very important. Okay, this just tells you it's on a straight line. EC is parallel to BF. Sorry, not on a straight line. It's just telling you the points that are relevant to you, such that in this case, AEB and CFD are straight lines. And what happens? You have to show that triangle ABQ and triangle DCP are, in this case, congruent. Okay, so I'll give you about 1 or 2 minutes, or maybe a minute to stare at this question. And for those who are fast enough, you can let me know. Okay, what is a particular test based on this notion given to me? So I have AB, okay, let me just draw it out to what I have. AB is parallel to CD. Okay, and I have AB is equals to CD. Okay, and I also have EC is parallel to BF. So, what is a particular test? Just shoot it out in your mind, because this one requires some steps. What is a particular test that comes to your mind when you have such a diagram and all this information are sort of given to you? Take note, it's congruent. Okay, I have one. Okay, no worries, no worries. It is hard for you if you don't write it out. Don't worry about it. No worries, okay? Okay, no worries, okay? Isabel gave me an answer already. For the rest, I'll give you all some time to think about it as well. Okay, because this can be a question that comes out in your exam. Or if not, something very similar. Okay, but then while you are thinking, again, let me just recall your congruence. When we prove congruence, your vertices have to be corresponding. So if I want to prove ABQ is corresponding to, in this case, DCP, your vertices have to be corresponding to each other. And yes, Denise has given me an answer as well. I'll just wait for a few more seconds before I go through. Okay, seems like it's taking a while, but yes, okay. Most of you got me the answer. Some of you say SAS, some of you say ASA, AAS. They are the same thing. But yes, okay, the first thing it comes to your mind because not much sides are given and parallel. So when it comes to parallel, you may think, okay, angles come to mind. So when angles comes to mind, what are the, when angles comes to mind, what is the first thing that links to you? So what properties can you use over here for this question? What is the first property that you identify that you can use? In this case, Isabel and Denise are correct. You're approaching it correctly because there are not much sides. You can use AAS or ASA. Both are acceptable. So what is an angle we can prove equal first? Based on what we have. Okay, so take note. There is, let me just draw the triangle first. In this case, if you are not sure. So I have A, B, Q, and I have D, C, P. All right, A, B, Q, D, C, P. A, B, Q, D, C, P. Yes, I have my angles over here. Okay, this is a little bit hard to see. In this case, you may wonder, even though they say parallel, the sides are not necessarily labeled. The sides are not necessarily labeled. Okay, but of course, one of the sides we can use is definitely this one over here. Because one side is given, right? One side is given. So that's where the S comes from. So let's write it down first. So write the common thing that we have as AB is equals to CD. That's the common side. It's given to us. AB is equals to CD. In fact, it corresponds there. Thing to take note, we cannot write CD. We have to write DC. Okay? Because A corresponds to D, B corresponds to C. AB is equals to DC. Very important. So that's the given side. So we have one side down. Okay, you can say AAS later, but we write the most obvious things down first. Okay, let's get them down first. So this is the side. Now, any other things that we can come in mind over here? Okay, so we have found one side. Now we just need two more angles. Let's check. Okay, I have B corresponds to C. Is there anything I can come about that? Well, it may be clear. Okay, but let's view something a bit clearer. Let me give you a hint. I have A here. I have D here. Is there a particular property that I can use to show that a pair of angles, not two angles, a pair of angles are equal? Very nice, Isabel. That's actually correct. Anybody else still wants to wait? Let me just see. Okay, the property is correct, Isabel, but the angles you might have chosen, it's not correct. You want to take a look again? The property is correct, but the angles you have chosen may not be correct. I'll just give you a while. Okay, so what Isabel have mentioned, okay, let me give you a hint. We can use alternate angles to prove one of the angles here. Okay, because what happens? Recall, when we look at parallel over here, linked to your Sec 1 basic geometry, you have three things over here you can use. Corresponding, alternate, interior. So in this case, your three famous letters, Z, F, and C. Alright, Z, F, and C. Okay, so let me take a look. So I have, okay, yes, that is in fact correct. You can use that particular angle as well. Yes, that is correct, yes. And then you can use angle, let me just see, BAQN. Yes, that's right, you can use that as well. Yes, in fact, what happens is you can use that as well. Okay, very nice note. Okay, in fact, your proof is a little bit different from mine, but let's see how it goes. Okay, so I'm gonna use Isabel's one of the answers first, and in fact, I will actually show what Isabel has done for me, which is a very nice proof over here. Okay, so let me just get started, right? So if you were to actually take a look over here, if you look at this Z, okay, this is my Z over here. AB is parallel to CD. I can essentially show that BAQ, in this case BAQ, it's equals to this angle over here. So we write it down because there's a letter Z over here. There's a letter Z. So what happens? We have angle BAQ is equals to, in this case, we have to correspond to the particular letters. Very important. CDP. CDP. Okay, this is also because alternate angles. And when we talk about alternate angles, very important note over here, we have to specify the sides that are parallel, because if my sides are not parallel, I cannot specify my alternate angles. AB parallel to CD. Okay, this is the angle part. Now, another nice note over here that Isabel has mentioned, okay, which I find very sharp, okay, over here. In fact, it's much better than the proof that I provided for my side, is that if you realize that since these two are parallel and my points over here, in this case, let me just take a look. E is a point and P is a point on, okay, A, D, B, okay. Okay. I understand in this case why your side may not work in this case, Isabel. Let me mention later on. But it's a smart way over here. It's a smart way over here. But I'll mention why your side may not work. Okay. Your first one is correct, but the second one may not work in this case. What you have mentioned over here, angle DPC, and in this case, angle AQB may not work. Why is that so? Okay. But let me mention my side of the proof first. Okay. What happens is, okay, I can actually show if this is a parallelogram, I can show that ABQ is equals to DCP, right? Okay. So in order to show that, what happens? We have to prove we need to first prove that, in this case, firstly, okay, my shape over here, EBFC, what is it? It is a parallelogram. In order to show what I've seen just now, opposite angles in a parallelogram, okay? So we work backwards. Now, how to show it is a parallelogram first? Okay, so we are almost there, just that it's a long-winded one. Okay, so in order to show this. Okay, now, how does this work? Okay, first step, okay, we know that in this case, AB is parallel to CD. Since E is a point on B, and F is a point on CD, it will be clear that in this case, okay, it will be clear in this case that EB, it's parallel to CF. This will be as such. This will be as such, so parallel as such. And also, the other side is also given that these two are parallel as well. EC is parallel to BF. This is given. Okay, so we have two sides being parallel, and doesn't that show that it is a parallelogram? So that's where we can conclude, since EB is parallel to CF and my EC is parallel to BF, okay, then I can finally say my EBFC, sorry for that, sorry for the sudden pause, my EBFC is a parallelogram. I understand that I might be blocking the word, so I will disappear in a moment. Just give me a while. It's a parallelogram. Oh, I'm not blocking it. That's a good sign. Okay. Now, what happens is this. With that, since it's a parallelogram, okay, what happens? I can therefore show that my angle at B over here, my angle at B over here, okay, this implies EBF. Okay, remember when you write the angle, it has to show the angle property here. Angle EBF is equals to, okay, the angle over here. Very important. Just write it out. In this case, over here, I'll just write ECF. Okay, which is then corresponding to what we want. Okay, back to this question. A, B, Q is equals to DCP. Because they are all in a straight line, so no problem. AB in a straight line as EB. And look at or try to actually understand what I said just now. Because based on the solution that Isabel gave, okay, if you want to prove that this angle is alternate, okay, which I'll get to later, so these are opposite angles in a parallelogram. Okay, this one I'm definitely blocking it already. Just give me a while. Okay, so I have angle, side. So therefore, I have. Okay, so since I have angle, side, I have ABQ. We will call your congruence way of writing it ABQ. It's congruent to DCP. Okay, remember to write the test you have written. Okay, I'll just disappear for a while. Remember to write the test you have written. So AAS, congruence test. Okay, so just write down the whole working over here. So the property over here I mentioned just now is that you have to prove that it's a parallelogram before you can use the opposite angles. Then you may ask, okay, teacher, why is it that I must prove that it's an opposite angle in a parallelogram? Why is it that I must write opposite angles in a parallelogram, but not straight away say alternate angles over here? Okay, Denise, to answer your question, okay, yes, you can write that. You can write that as well, but because this is in a way, you can write that, yes, because essentially they are the same angles. If you're talking about FCE, and in this case, ECF, yes, they are the same angles. But just make sure when you write corresponding, make sure you write when you write your congruent angles, it has to be corresponding to the vertices here. Okay, let me make myself appear because it's a little bit weird now. Okay, now, some of you may ask, okay, why don't the alternate angles here work? Look at the question. Did the question specify that A, P, Q, D is a straight line? Or in this case, P and Q are points on the line AD. So this is a very, very vague thing, because if they did not mention, we try not to assume that it happens. Okay, so that's why. So that's very, very important over here. So even though the diagram, very, very important over here, okay, this is a little trick that a lot of schools like to do. Even though it looks like a straight line, if the question never specified that it is a straight line. Did I write side here? No, it's not side, sorry, angle. Even though it looks like a straight line, you cannot assume that point lies on a straight line. Okay? If it's a straight line, they will draw, but whether that point lies in particularly on a straight line or not, we cannot assume. It's a little bit vague over here, but if the question doesn't specify, please do not assume. Okay? That is that. Okay, so side, angle, and then the hardest part is to see the parallelogram and find the angle again. Okay? Now with this, let's just try to see whether we can answer it over here. With the first bubble question, whether, or in this case, what are the parallelograms that we need to use for this question? Okay, in this case, to show this proof. Well, the question has to specify to play it safe. Alright, that needs to play it safe, yes. Okay, launching the bubble launcher, just specify my parallelograms in 3, 2, 1, let's go. Okay, remember to specify my parallelograms accurately. The vertices play an important part over here. In this case, this is one very good example that both points lie on the straight line. 2 points lie on the straight line. E and F here lies on the straight line DC. Then I can say that they lie on the straight line. But then again, I'm only here to ask you to identify the parallelograms. Alright, so identify it. Okay, last 10 seconds. I think most of you all got my parallelograms. Remember, for questions like this, the order is very important. Okay, I think most of you all got it, but let's see. Okay, so what is the parallelogram used in the question? I have two lines parallel here, so I have ABCD is a parallelogram, so immediately we know the top and bottom has to be parallel. E and F lie on DC such that AE it's parallel to BC, and in this case AD it's parallel to BF. So immediately you should know that it's ABCE, and in this case, let me just see, A, B, C, E, and A, B, F, D. That's why my answer is number 4. Okay, the order of the vertices does matter if we were to label our parallelograms. All right. Now moving up next with our parallelograms. What do we need to do to ensure that my triangles are congruent? Why am I pausing there? I had a brain freeze just now. Triangles ADE and BFC. What is the particular test we are using for? Okay, so what happens? Okay, do all the tests. Okay, don't just do guess and check. I want you to do all the tests. This one is quite a bit, and also take note of the two parallelograms that you have used just now. So I have my parallelograms. We call two parallelograms ABFE, ABFD, and ABCE. Okay, which one do we use, or do we need to use both? All right, launching my bubble launcher in 3, 2, 1. Let's go. All right, try to do all the tests. Is very important over here if you want to get this down. All right, very important. Again, certain things you can assume already. In this case, because it's a parallelogram. No, it's not a parallelogram. Okay, it is these things over here. Part A is the thought process, but part B is what you need to actually show it out. Okay, over here, I'm just writing out what is given in the question here. We have 1 minute left. Let's see how you guys can do this accordingly. Okay, try to do out the proof. Don't do guess and check, because if you guess and check, you are not trying to follow the thought process to how you are able to prove this out. Alright, so think positively. Try to do more what you are able to do. Alright. Okay, seems like most of you got it and stuck between two particular tests based on the results I have. Okay, I do now have a mixture of responses. Okay, last 12 seconds. Last 3. Alright, okay, not too bad. I would say most of you got it, but let's see what we can do over here. So most of you got it right. It's AAS, but what are the two angles and the side that I need to look out for? So take note, remember your vertices. I want ADE correspond to BFC. So take note first, what are the angles that are easy to find? Okay, again, if you are confused, always try to write out or highlight out my triangles. ADE, BFC. So we try to see which are the angles that we can do first. Okay, first up, okay, we try to see in this case, oh, I have actually two angles that I can make use of. First up, I have, okay, ADE is equals to BFC. First one here. Okay. I hope you all realize the property over here, ADE equals to BFC, because my angles are corresponding angles. Okay, and you have to show the sides that are parallel. Take note, you don't just anyhow include any two sides, but the side that is relevant. So AD parallel to, in this case, BF. Next one, there's also another side as well. Okay, I have AED is equals to, in this case, BCF. Again, corresponding as well. BCF. So in this case, I'm using my sides AE and BC. Okay, so this is the angle over here. Now in this case, take note, AA test doesn't work here. If you were to solve these two angles, you will know that this is number 2 already. Cannot be 1, cannot be 3, cannot be 4. But what's the last side? How do we find it? In this case, that is where we have to prove that there is a certain parallelogram that is happening. Okay? Because parallelogram, what is the characteristics? 2 pair of parallel sides and 1 pair, both lengths are equal. The other pair over here, both lengths are equal as well. But which parallelogram do we use? In fact, what happens, you can use, in this case, either AB, ABCE, or ABFD. Doesn't matter. AAS, ASA doesn't really matter. So therefore, in this case, we can just show one of the parallelograms. So the first one, in this case, to show, in this case, let's say, I want to show this one, ABFD. So how would I show it? First one, very simple. I have AB, it's parallel to DF. Alright, this is quite clear because it's trapezium. Alright, it's a trapezium, 1 pair of sides have to be parallel. Okay, next one, even clearer, AD, it's also parallel to BF. It's given in this case. It's given in the question. It's given in the question. I'm not blowing out from thin air. It's given in the question. AB parallel to DF. BF, yes, BF. Given in the question. Now, with these two, because I have 2 pair of parallel sides, therefore I know that ABFD. Take note, the orders have to matter. ABFD. Okay. In fact, in a clockwise motion, yes, clockwise motion, ABFD. It's a parallelogram. And with that, we can actually just use the side that is relevant. Either AD, BF. In this case, the side that is relevant. Therefore, I use this side. AB equals to BF. AD equals to BF. I mentioned over there. AD equals to BF. That's such a tongue twister over here. AD equals to BF. That's a side. And therefore, you have one angle, another angle, and lastly, another side. This therefore gives you the congruence test of AAS. So ADE congruent to BFC. And most importantly, you have to specify the test you are using. So AAS congruence test. Alright, so that's how we can make use of parallelograms to solve an important pointer over here, which thankful that Isabel provided her feedback. Okay, you have to see in the question that it specifies that it lies on a straight line. Then we know it lies on a straight line. Alright, very important note over here. Okay, quite a long question, but next one, let's do a recap. Ratios of area of similar figures. If A1, A2 are the ratios over here, what can I use for the L1 and L2 specifically? What is the ratio I can use here? Can anybody tell me? Okay, this is a good recap over here. Hint, there's something got to do with me doing a certain notion over here. Very good, Denise. Anybody else wants to try? Very good. Very good. Okay, Isabel, I think that's a typo, but I get what you mean. So L1, L2, I square it out. Yes, I got you, Isabel. Don't worry, don't worry. I think you just had your lunch, so that's where it comes in, but don't worry about it. Okay, now what can I do with such a question that combines all the concepts together? So look at this question. I have two circles that touch a C, so that's where certain properties come into mind. Look very carefully over here. So I have a circle where the center is M, a large circle where the circle is N, M and N, okay? And it has to be specified. A, M, C, and E, and B, C, D are straight lines. Only when the question specifies, then you can say, oh, these two are my straight lines. Okay, looking at this question again, I'll give you a few more minutes to think of I would say 30 seconds to think about it. What is a test I can use over here? So this one, I think it's quite straightforward, but what is a test on first glance based on the question over here that you can use? Yeah, anybody want to try? Very nice, Denise. In fact, you have proven all the particular notions over here. Okay, take note while I wait for everyone over here. Let me just write it out again. Similar triangle CBA, okay, corresponds to my vertices CDE. Okay, take note. This is the same for similarity and congruence as well. Always write your vertices down. All right, Isabel, provide the answer as well. Very good. Okay, anybody else who wants to try before I provide the actual working down? Alright, if not, good job over here. Okay, so you realize over here, since it passes through the center and not much size is given, there's only AA. Okay, so what happens? What's the first angle? In fact, this particular property, it's very commonly used. It's what we call the VOA. I've just learned some acronym they use, or in this case, it's nothing new. It's just vertically opposite angles. Okay, but in this case, we have to write out vertically opposite angles. In this case, BCA is equals to DCE. You have to write out vertically opposite angles. Okay, you cannot write VOA because VOA represents a lot of things. In this case, it may represent visa on arrival for those who have traveled. Okay, and next one. Okay, with this particular angle. Okay, in fact, Denise has provided me the answer, so I'll just follow up from there. Next angle is actually this angle over here. And this angle, I can assume it to be 90 degrees because if you refer to your properties that we have recapped quite last week, if I recall, CBA is actually equals to CDE. Because, and both are 90 degrees because they are angles in a I almost said triangle, sorry, semicircle. So once you've written down the proof, and always remember when you write down your angle properties, you have to write down the abbreviations. Very important. And finally, you have to write down the concluding statement. I cannot see what you write, but always remember to write down the concluding statement, which is CBA, and my triangle CDE are similar. And you also have to write down the test you are using, which is in this case my A similarity test. Alright, very important. You have to write down the test you are using. Alright, you have to write down the test you are using. And I believe I have asked you all why we don't need to find the last angle already, so I'll skip that part. And with that, let's go on to bubble question number 3. Recall, okay, I am not going to ask you to guess. Recall that these two triangles are similar. Okay, that's the very big hint already. Recall these two triangles are similar. How am I going to solve bubble question number 3? Okay, launching the bubble launcher in 3, 2, 1. Alright, let's go. Alright, very nice, very good. That's a good start over there. Very nice. Okay, you just have a little more than 20 seconds. Last 10 seconds. Last 5, I think most of you got it. That's a good note over there. Based on the responses, I think you guys got it. Good job over here. Give yourself a pat on the back. But for those who did not, don't worry about it. I'll go through accordingly. Now, when you are given the ratio and afterwards you want to find the area, that's where you know the area formula should come into play. So how should I do it? Again, area of CBA over, in this case, we can find the fraction first. Fraction, it's the similar notion of ratio, just that the representation is different. Is equals to CDE. Take note, in this case, small circle, my radius is 4 cm. Large circle, my radius is 9 cm. How do I solve this? Take note, CBA is the small radius, but in this case, we cannot use the radius because it is not part of the whole circle. We have to use the diameter, d1 over d2 squared. Even though in this case your answer will be the same, but take note you have to use the diameter. If not, you'll fall in the trap of number 4 if you forget to square. That's where I know some of you chose the radius. Next up, what happens is diameter is just twice of it, 8 over 18. Square. And that's where you can simplify. In this case, it's going to be the same, but working-wise, you might be marked out. And therefore, 16 over 81. Now, in this case, some of you may click the option already, but in your working, please take note to write down the finishing statement over here. Area of CBA, it's with the ratio to area of CDE is 16:81. So very important note over here, and that's why number 3 is my answer. Alright, very important note. Alright, so I hope you all got this down perfectly. Now next one, this is the harder one over here. I have, in this case, okay, I'm gonna label to you everything you need. This is 4. This is 9. And I'm going to tell you this is 48 degrees. Now, how are you actually going to solve for the shaded area? Okay, this is quite some steps you need, so I'm going to give you quite a bit of time. Look through the question first before I launch the bubble launcher on my site. You will need quite some time, so I'm not going to launch it first. You can start your working now before I launch it in 30 seconds, alright? Ten more seconds before I launch the bubble launcher. Alright, in 3, 2, 1, let's go. Alright, so let's see my responses over here. And yes, just be very, very careful over here, alright? Now take note, when you write your workings, be sure of the concepts you're using here. Recall, there are a lot of concepts here that are applied, and in fact, one of them it's from Sec 3E. If I'm not wrong, you only learn that at Sec 3. So for those who are, I do have a mixture of Sec 2 students and Sec 1 students as well. So if you're not sure of this concept, it's okay, but if you want to give it a try, do try the hit. You have about 1 minute left, give it a shot. Last 45 seconds. While looking at the responses, I'm heartened. Just be careful of the angle that you are actually using over here. Last 25 seconds. Always remember, you guys are awesome. Keep it up. Maintain the stride. Alright. Last 15 seconds to go. Lost 10. Last 5. Alright, I think I would say most of you got it. That's a good thing. But for those who did not, this is a little bit complicated. So let's see how we do. So if you realize over here, this is actually none other than the area of your sector. So how do we do it? Okay, first up, angles, you realize both of them are the same. What do I mean? You have angle BCA is equals to angle DCE. This is equals to angle 48 degrees. What did I say? Angle 48 degrees. 48 degrees. Again, you have to say the reason to why they are equal, because vertically opposite angles. Write it out. Okay. Next one. In order to find my shaded area, you realize I need these two beautiful angles over here. And since M and N are my center, I can say this. I can say BMA is equals to DNE is equals to, because it is twice the angle. So 45 degrees, 48 degrees times 2 is equals to 96 degrees. Because recap from last week's lesson, angle at center is equals to 2 times of angle at my circumference. And from there, I hope you all realize what's the formula for shaded area for this one and this one as well. This is none other than, this is equals to the ratio of the angles with respect to degrees. Remember the degree sign, multiplied by the area. So first one will be pi. Let's say I do the small one first. Actually, it doesn't matter. I do the big one, pi 9 square. So let's say I do for this area first, plus again the other area, 96 degrees over 360 degrees, multiplied by pi 4 square. Summing it up, you can press your calculator, write in 5SF first, 81262, simplify to 3SF, 81.3 cm squared. That is 3SF. And that's how you get the answer. Now, one way they can make the question a little bit harder is they can ask you to find this as the shaded area itself. Now, if I were to just find this shaded area, the new shaded area, in red instead of just gray, can anybody tell me what's the additional step that I should do instead? After I find my shaded area, what's the additional step I should do? Just to test the understanding over here. Is there any additional step I should do over here? If my shaded area is only the red color one, I'll just wait for 30 seconds. Right, very good, Denise. That's actually the answer. Anybody else wants to try? Okay, I believe you guys, some of you are still thinking and most of you got it already. But in fact, to specify what Denise said, you just need to minus the triangles over here to find the segment. In this case, the same thing, just that you have to be understanding of my triangle formula, which is half AB sine C, where AB is the side and C is my included angle. In this case, my sides are the same, but it may not necessarily be. Okay, so just take note from there, and let's move on to the last example over here. So take note, if ratio of area, I do my square. Volume, what should I do? What should I do to my volume instead? So something with L1, L2, definitely. I need to have my bracket, definitely. But what should I do? Very good, Dylan. Very good, Denise. Perfect job. I should actually do a cube. Okay, this is learned in your Sec 2, if I'm not wrong. Yes, Sec 2. Sec 2, you actually learn Sec 2? Yes. Yes, Sec 2. You do actually touch on this in Sec 2 as you go on to areas and volumes of similar figures. Okay, next up, mass as well. Okay, this also applies as well because your mass will be equals to the volume and you actually cube it accordingly, but it only applies, take note, if it's the same material and they share the same density. A little bit of physics here, but it definitely is true. If they do not share the same material, in this case, one is made of cloth and then another one is made of air, definitely they do not have the same density. Okay, so that is very, very important over here. And now, with that, let's have an example, shall we? Okay, so let's take a look over here. I have a steel frustum. It's made by moving a small cone from a large cone, shown in the diagram. The right side shows the side view. So similar triangles, to find the value of x, they should be rather clear. Okay, they tell you it's similar triangles already, so you don't need to prove the similar triangles. Can anybody tell me what is one ratio that we can use over here? What is one ratio we can use over here to prove this one of the similar triangles? What are the two sides we can use first? Okay, let me do a start first. So when I do my particular triangles, maybe my question isn't clear, so let me just write it out. I hope you all realize for similar triangles, it has to be respective. So the small one with the big one, or the big one with the small one. So in this case, let's say I do the first side. So similar triangles, big side with the small side, over with the other big side and the small side. So let's say my first big side, I will do x over 2.5. Then can anybody tell me what are the other two numbers I can fill in for my similar triangle fraction on my right hand side? What are the other two numbers? Anybody who wants to try? Okay, very good, Denise, that's actually correct. Why the sad face? Okay, I have 12 and 3. So with that, I can find x, which is 12 over 3 times 2.5, which is 10. So therefore, x is 10. Right? Yes, it is hard, but once you get the notion, you got it right. So you shouldn't be sad. Pranav, good job over there. Eh? I'm seeing you again. Hi, Pranav. Okay, I know it's hard, but that's where you have the similar triangles. Identify what's the long side, short side. If this is hard, you can draw out my triangles as well. If 2.5 corresponds to 3, then my big triangle, if this is x, then it should correspond to the height. So I can draw two separate triangles and hope that it will be helpful down there. Okay, draw my two separate triangles. And I think I'm blocking the triangles, yes, but I can draw them here. Okay, now, with this notion over here, we can actually say that this is none other than what we want to find. So x is, in this case, let's see, 10. Next part, it's not so straightforward, but take a look at this. Calculate the mass of this steel frustum if the mass of the large cone decreases by 38.3 gram. Okay, so what's the question asking for? They're asking for the mass of this, but take note over here, the mass of the large cone decreased by 38.3 gram. Now, can anybody tell me, let's say I label as such. This is 1, this is 2. My whole cone here, let's say, is 3. Can anybody respond? The 38.3 gram, what does it correspond to? 1, 2, or 3? 1 being the large part, 2 being the small part, 3 being the whole cone. Try to visualize again. My mass decreased by 38.3. So 1 being the whole cone, 1 being the frustum over here, 2 being the small cone, 3 being the whole cone. So what is the 38.3 represent over here? Okay. Alright, very good. Okay, I think some of you all noticed already 38.3 because it's decreased. So this part is removed. So I do hope you all realize that in this case. Very good, Denise. Including a response as well. My mass of the small cone is going to be 38.3 gram. Now, how is this useful? Now, take note, how do I form my frustum? It's removing a small cone from the large cone, and take note, they are similar. So that's where you realize when it comes to similar, volume comes in M2 over M1. Take note, M1 we said it's the small cone, so M2 it's for the big cone. We have L2 over L1. Take note, I cube it. And in this case, I can cube because they are the same cone, same density. Okay, so if I want to solve, I'm solving for M2 now. So I have 12 over 3. So I'm just using one side over here, so 12 over 3. Take note over there, alright? Multiply by 38.3. Take your calculator, press, you're going to get 2451.2 gram. Now, is this my final answer? Take note, they want the frustum, so it's this part. What you have achieved is this one. You need to do something else. So you need to actually subtract. So mass of frustum is equals to, in this case, M2 minus M1. So a subtraction is required. So you are not just solving for the mass, you have to do a little bit of something. If do a little bit of something first. So 24.51.2 minus 38.3. And you get the answer. And to answer Denise's question, if you feel that drawing out helps you solve better instead of trying to squeeze your brain power to split the cones in your brain, I'd rather you draw out. I'd rather you waste a little bit of time so they can visualize better than waste more time to try to decipher the drawing and you get a further headache from that. So if you rather draw it out first, go ahead. And take note, the question was 3SF, so 1, 2, 3. I'm looking at the number 2 here, so we round down. So 24.10. Great. Okay, no worries, Denise. Alright, so sometimes time wasted may not be so wasteful after all. You understand what I mean? Okay, so with that, we just have actually 2 more bubble questions and we are done for today. Okay, so similar notion over here. Use similar triangles to find the value of x. Alright, launching my bubble launcher in 3, 2, 1. Let's go. Similar triangles, this one should be alright. Follow the notion at the top, it will be okay. Okay, you realize that this is very, very similar to the notion we have. Just that we are moving something a little bit different here. Last 30 seconds. So I hope you all identify the similar triangles. In this case, similar notion, identify which is my small, which is my big triangle, and then we solve from there. Just that there's a little twist over here. Okay, last 5 seconds. Alright, let me take a look. Okay, most of you got it, that's a good sign. For those who did not, just be very, very careful. Some of you are just apply, in this case, the wrong ratio. Alright, so just be very, very careful over here. Okay, now, when we apply the ratio, take note, this is the small height for the small triangle. 14 minus x, because 14x, this should be 14 minus x. Alright, so 14 minus x over 14. L2 should be 6 over 10. Huh? Some of you all put 6 over 14, which is why you got it wrong. So 6 over 10. From here, it is very similar to how you solve your linear equations. Cross multiply. So 14 minus x, or in fact, I just multiply 14 to my right. So I'll get 14 minus x is equals to 8.4. X is just 5.6. So most of you got it right. Good job. Have a pat on the back. For those who did not, just be very careful not to apply your ratios wrongly. Okay, now last bubble question for today. Just nice. I'm gonna exit a little bit over here. So do I need anything? Okay, so let me just write out a few stuff for you. Okay, so this is 5.6. So this is, okay, what we have solved. So if this is 5.6, this is gonna be You all can start solving first. Look at the question and solve first. Alright, while I write the details needed. 5.6 and see how you would solve. It's very similar to the previous work example, just that right now we are solving for different stuff. Okay, launching the bubble launcher. Now in 3, 2, 1, let's go. Alright, going good. I have about 1 minute left. Okay, time is 3. For those who are in the rush after this bubble question, you can go. But after that, for those who are willing to stay with me to sum up certain stuff, you can feel free to stay with me as well. Alright. I hope my handwriting is clear. Okay. It's good. Okay, I have about 45 seconds left and most of the responses are going good. Going very well, I would say. This is a little more straightforward, I would say. That's a very good note. Alright, very good note on taking note of that. Very good note in taking on that, Denise, but don't worry about it. Let me just see. Okay, yes, we will take note. Okay, don't worry about it, Denise, we will take note, but you can just circle that option right there. Alright. Okay, time's up. Okay. Yes, take note. Thank you for the note, Denise, but don't worry, the answer and thought process is there. Okay, sorry for not taking note over here. Okay, now what happens? If I have M1 and M2, because how we know this? Mass of the glass pyramid is the larger pyramid. So immediately, glass pyramid we know is a smaller one. The larger one it's 1260 gram. So what we do, L1 over L2. Over here, use a ratio that is easier. In this case, whole numbers. So therefore, I can straight away apply, in this case, M1 over 1260 equals to, in this case, 6 over 10. Please do not torture yourself and use decimals. Alright, it is quite painful enough for math already for some of you all. Okay, multiply by, in this case, to find M1. So if I want to find M1, just multiply 1260. Okay, some of you all realize it's 272.16. Okay, this is essentially this answer. But answer asks for 3SF, so this is not correct. But again, the answer is the same. So for those who chose 8, there is no refund of bubbles because the answer is still essentially 272. Alright, apologies for that. We'll take note for future lessons. But I do hope you guys know where the concepts comes from, where regardless or not. Okay, remember 3SF. Okay, with that, that is actually it for today. So what happens is there's a Genie Ask Questions. Try it out accordingly. Okay, very similar to what we have went through before. Do give it a shot. 40 bubbles up for grabs. Not only you can recap our concepts, you can also get bubbles, maybe to redeem a gift for Father's Day. It's coming soon. And yes, so the tip of the day, recall, very important. This is went through before already, but just a recap. If a pair of congruent or similar figures are given a question, we have to write them in the corresponding order. A habit to that it's referred to in the previous work examples and bubble questions as well. Okay, so that's all for today. What have we recapped? Congruence and similarities. Congruence figures both are equal. Similar figures, one equal, one proportional. Congruence test you have 4. AAS, ASA doesn't matter. Similarity test you only have 3. Take note, only AA. No need AAA. Okay. Area and volume. Area you square, volume you cube. Solids of the same density. If you're looking at mass, you cube. Take note, it has to be of the same density. Okay. Alright, that's actually all for me today. Thank you very much for staying with me. This is Teacher Jason signing off. If there's any help that you need for any subsequent concepts over here, feel free to approach me for a short Q&A. Otherwise, thank you so much. This is Teacher Jason signing off. And I'll see you again next week, same time. Alright, take care. Bye bye.